far field, it is very sparsely spaced. How to move this, sir? How to move this? Okay. We will show one case how to make the single center line petard pressure. Okay. We have to go to the plot, go to XY plot, and then write the, first we will see the velocity in Mach number. Okay. Axial Mach number. Okay. You can see the axial Mach number. This is NPR 3. But why there is a high jump here? That is why. Okay. Okay, total pressure. There is a jump. That is okay.
Here only it starts.
Zero. Here only it starts. Okay. So first we have to write. So can we open Sharma and show first students how it looks like the center line? Pitata. Sharma paper. We will open Sharma paper and we will show how it looks like. Okay, Sharma, it's already open. NPR 3. So this will be your NPR 3. But PT by PT not.
Then we have to do one.
Okay, this is total pressure. From here we have to take. Okay.
From 0.
Actually, sir, that is petard pressure. But we have to make it. This is total pressure. This is not petard pressure. So to get to petard pressure, we have to use Rayleigh-Petard tube formula.
We have to
Convert. So I think you can open an Excel sheet where you have already used the Rayleigh-Petard tube formula. You can open one Excel sheet.
Yeah.
No, already you have done post-processing. No, that Excel sheet you open. For supersonic or sonic underexpanded. You open, sir. Anyone? There 12. Any one case and data. Not used? No, I need one Rayleigh-Petard. You have done, no? Post processing you didn't do. Under expansion. Under expansion only we are doing now. Okay, like this, sir. So where is the original case and data for this file? PNED under expansion.
Yes,
You
sir.
open that case and data. I don't know. For this one, 12 mm. Sorry.
Everything is there. It's 91.
No, sir. Any one case and data file you open, sir, for sample. Okay. Okay. No, you open in case and data file. Open as case and data file. Read. But it's not seen here clearly. Whatever you are doing is not seen here. Okay. That is okay. That is okay. We are sharing only the fluent file. Single jet, SJ. Then we will do now. We will do now. You will do now. Yeah, since you have not done, we will do now. NPR 3. Okay. Okay. Rajakumar, XY plot. First you plot and see. Plot the tot. We need a, I think, Mach number, absolute pressure. That's all. Correct? Total pressure. And the total pressure. Okay. So you first write. First you see static pressure, total pressure. You see first for the axis. It will come like this. Okay. This is the total pressure plot. Sir, can we see share the entire screen? Entire screen is not seen. Where I can see the entire screen. Console graphics. Okay. So this is the total pressure. You have to write this. Okay. So you have to write this file XY plot pressure total pressure. Okay. Axis save plot. You have to click this right to pay. This is not showing. No. This dialog box you cannot see. Rajkumar. Okay. Now again I have to go and change to present something else. To get the Rayleigh-Petard pressure is nothing but you can see here. The Rayleigh-Petard pressure you can see. It is the combination of three things. You know what is Rayleigh-Petard formula? Okay, just type Rayleigh-Petard tube formula. Okay, there is a big formula. Okay. So actually, what is that? You can see in the screen. It connects the Petard pressure. Okay, Petard pressure, static pressure in terms of Mach number. Okay, so that is the idea. So what Sir has done is that he has already converted. He has used Rayleigh-Petard formula. You can see here. He has used Rayleigh-Petard formula, and he has converted the absolute pressure, gauge pressure, and Mach number to Rayleigh-Petard, such that we can compare that with the experimental curve. Okay. So now you can see. So we are going to do the same for the single jet. So first we will copy this sheet and then we will use it here for the sake of time. Okay. So I am doing for NPR 3. Okay. So now I am going to get a Mach number, absolute pressure, total pressure. Clear? So gauge total pressure. So you will see how to get it. Just you click XY plot. We have already plotted the total pressure across the axis. So this is the total pressure across the axis. Okay. So that you write to file, click write to file, and then okay, we will put it in some other Windows. Okay, D drive. We'll put in some other folder for our convenience. New folder. Arrange. So now here I will save as total pressure. CLTP, center line, total pressure, I'll say. Okay. Now, the same Excel sheet, if you go, file, open, you go to that place, browse, D, Naren, you click all files, that will not be saved as Excel file. Click all files, you give yes, next, you enable semicolon, comma, space, then click next, then click finished. So whatever you have written will come like this as a separate Excel file. Clear? Okay. So this is X, this is your total pressure. So in the sheet, base sheet, you have X separately, total pressure separately. Sarah started from 0. Okay. So we will also start from 0. You just first click and just select, and then you can paste it there. You can paste it there. X in mm, paste the values. So you have pasted the values. Next one will be, okay, you have pasted the values. Next one will be, I need a total pressure. Okay, total pressure is in gauge. Okay, so this is gauge total pressure. You can see Control C and just copying and pasting. Okay, you can paste here. It is gauge total pressure. It is not total pressure, it is gauge total pressure. Okay, and then so that if you add with 101,325, it will become absolute total pressure. Okay, now I need absolute pressure. That means absolute static pressure. Don't confuse with the gauge, absolute and all. Total pressure, static pressure. So this, if I select here static pressure, it means static pressure alone. If I select here absolute pressure, it is absolute static pressure. So first to see whether you are getting absolute static pressure. Plot, you will get like this. Same way you put write to file, write. So you type CLSP, center line static pressure, and you click OK. So you can see there, file, open, browse. You can open the CLSP, you give yes, next, semicolon, comma, space, next, finish. So for the same case, you will get center line static pressure. So you copy the static pressure from here and paste in the base file. This is absolute pressure. So you paste here the static pressure. Okay, now next I need the Mach number. So first you see, you open Mach number and see velocity, Mach number. You just plot and see. Okay, now we have to write to file, write, you just write center line Mach number, CLMN. Okay, you click OK. Again, open the file, browse, center line Mach number, open, give yes, next, semicolon, comma, space, next, finish. So now this is the Mach number values. So you select the Mach number values, copy it, paste in the base file. Okay, so you are getting here. So X by D, SAR has done for 6 mm. For hours, it is 12 mm. So I have to put 12 divided by 1000. 12 divided by 1000 will be 0.012. Okay, 0.012. So you just put 0.012 and drag it. So your X by D will change. PT by P naught I have already calculated with respect to Rayleigh Pitta tube formula. And please understand this is for NPR 3. So you just just calculate for NPR 3. SAR has done for NPR 5. We have to do for NPR 3. Okay. Take calculator, just type 101,325 into 3. Okay. Somebody say 101,325 into 3, how much? 101,325 into 3. Why 101,325 into 3? 101,325 is the atmospheric pressure. Okay. ATM. One ATM is 101,325. So it is 303,975. It is 303,975. Okay, enter. Just drag it. And we are getting a value which is greater than 1. So that is not desirable. So what we will do, we will just see this value. Just know how much is this value. It is something more than 101,325. So you just have this value divided by that value. You will get 1. So you just drag it. So you will get some. So this is, we have plotted now. You have to see. Okay. The problem is that this very interesting thing here. See, you are getting num here. Okay, num means there is no number. So which means that your Rayleigh-Pitat formula is not working for the entire domain. So now what we have to do is that we have to see how much, for how much length. See, you can see here, it has become subsonic. It has become subsonic. This is 0.99 Mach. So here I should not use Rayleigh-Pitat formula. Rather, I should use the total pressure directly. Just delete it and just use the total pressure directly. Just give enter. And from here on, your total pressure will come. So that is why I am using total pressure here. Okay. So your num will go off now. You will get total pressure. Okay. So this is the idea. So if you plot this for NPR 3, okay, Chandrabose sir is going to make the nozzle. Okay, he has already given for fabrication. He is going to make the nozzle. Okay, so we can verify this experimentally also. Okay, so now, whatever, yeah, just select this and plot. Select this and plot. Okay, go to insert, scatter. Okay, so you'll get a plot like this. You will get a plot. This is your plot. Okay, you can see clearly. This is your XY plot. So this is the conventional Excel plot. Okay. So recently there are many tools like Origin Pro and all. So here this is your x-axis, which is x by d, and the y-axis is your PT by P naught. Okay. So your center line total pressure will look like this. Okay. You can enhance this diagram. That's all over. So this is like you can see here. You can see Sharma. You can see the nozzle looks like this. So our nozzle. Okay. So this is center line total pressure. You can change the axis orientations and all. You can keep the maximum 30. You can keep. It will look better. Here also you can change format axis, and you can put 1 as maximum. Okay, and you can see you can change the number. You can change decimal places. You need only 1. Okay, so like that you can change anything. You can see the potential core comes less than 5. Okay, it comes around 4. It's called the shock core, and then decay comes and then fully developed region. So this is the centerline pitot pressure of your nozzle. Clear? Any doubt? Any doubt, Rajkumar? Any doubt? Base file to you. So whatever post processing you are getting, you can just copy and paste in this, and then you will get it. And the important thing is you can just the whatever file you are saying, it will be saved as some text file. You should save it as Excel file. Only then the correct format you will get it. You save it as Excel file, CLTP, close it. CLMN also you will save it as Excel file. Save as browse, not tab limited, Excel workbook, save. Then you close it. And then CLSP, file, save as, browse. You will get Excel workbook, save, close it. And this is the base work. So I will give save as, browse. We will save in our folder itself, Naren. Okay. This is the base file. So these 4 files I will share, okay, to you. Clear? Post processing. Rajkumar, you can zoom and see. You can see how much 1, 2, 3, 4, 5, 6 shocks are there. Same 6 hours are visible there also. You can see in gray scale. Same thing you can see as gray scale. Okay. There are many options you can see as gray scale. Okay. So this is density contour. You can see any other contour like velocity contour. You can see velocity contour. This is the velocity contour. Clear? Same things you can use. Okay. For writing your paper or something like that. Okay. Clear? Any doubt, Rajkumar?